Hi everyone, and welcome to my video on Amazon Kinesis versus Amazon SQS. In this video, we will be comparing Amazon Kinesis and Amazon SQS service from AWS. Brief agenda, we will be comparing these two services. I will be explaining you what SQS has to offer, how SQS works. Similarly, what is Amazon Kinesis data stream and how does that work? And then we will be looking into the differences and top use cases for these two services. Before we start about these two services, let's understand where this sits in the wider AWS services space. Because if you look at it, they are part of the AWS Messaging Services. Amazon or AWS Messaging Services are divided into two categories: AWS Native Services and Managed Open Source Services. So if you take a look at it, the difference is AWS Native Services are actually developed internally by AWS, so they are proprietary to AWS. And the open source is open source, but with managed open source, what it does, AWS takes care of the infrastructure for you, so you don't have to worry about scaling up, scaling down, provisioning the servers and everything that comes to support these services. You can just start using it, start coding without taking care of the underlying hardware and infrastructure for these two services. Today, we're only going to look at these two categories, like event store and event routers. In the event store, we have two offerings: messaging queue and the stream. So in the messaging queue, today we will be looking at Amazon SQS versus the stream that we have, Amazon Kinesis data stream. So I can kind of see where the difference comes in from there, but still we often get confused because there is some overlap in terms of the features and how they can be used in different scenarios. So let's take a look at it. Before going ahead and jumping into the SQS and Kinesis comparison, let's take a look at it and start comparing event store and event routers, because often we get confused that we can achieve the same thing with Amazon SNS and event version with Kinesis stream. So it's very confusing in many use cases. So let's start comparing event store and event routers now. So if you take a look at the event store and router, as the name suggests, store acts as like a buffer between the producer and the consumer of the message. Messages are pulled by the consumer. So like producer is putting the message in the event store and consumer is coming to the store and taking the message from that store. Messages are persistent. So as long as the message is available in the store, there will be some persistency. So this message will be stored for X amount of time. And we will discuss that, what that means for these two services that we have. And both of them, they provide the ability to invoke Lambda functions with the batch event or a single event. And whereas the routers, as the name suggests, they kind of are routing the event from the producer to the consumer. So they allow you to decouple producers and the consumer. And the most famous use case is fan-out events, so that is the SNS. So this allows when you send the event, one event, then there will be subscriber to that particular event and they can receive this, like in case of SNS. When you put the event to one topic, there will be some subscribers to that topic and they can start receiving that event. This is a typical use case for PubSub. The major difference between the stores and the routers, it's come in the message push to the consumer. So the event router is actually pushing the event to the subscriber for that particular topic or the event that we're sending. There is automatic retry, so you can configure the number of retry that you will have for that particular event. And the filtering is also there, so you can decide which event should be pushed to which consumer. So the filtering is kind of owned by that router. So this is the major difference. And the best part is that event routers can be chained with event store. So what that means, you can route your event to the event store. So these two goes hand in hand. So now you would be able to understand where you should be using event routers and where you should be using event store. I hope this is clear now. Now let's move on to Amazon SQS. So Amazon SQS, this offer, again, it's a part of the event store offering from AWS. So this kind of has all the features and the attributes that we have for the event store. Plus, the message retention period in SQS can be anywhere from 1 minute to 14 days, and default is 4 days. SQS offers two variants, standard queue and FIFO queue. The key differences between a standard and FIFO queue are: standard queue provide best effort ordering. What that means, when you are sending the event to the queue, standard queue will make sure that, or will not make sure, will try to maintain the ordering, but no guarantees there. So order can be different, like when you put a message 1 and message 2, message 3, the sequence can be different when the consumer takes that event from the queue. Whereas in FIFO queue, this is first in, first out delivery. So there is a guarantee that there will be a guaranteed ordering of the event. The first event that you will be putting in the queue will be consumed first by the consumer. Second difference, standard queue offer at least once delivery. So what that means, one event can be delivered more than one time to a given consumer. With FIFO, this ensures that you can only deliver a message exactly once. So this is kind of the use case where you want to make sure that if you, let's say, you're sending the communication to the user, order confirmation email, you want to make sure that you're only sending that order confirmation email once. That's where the exactly once kind of the delivery comes into play. Second, the standard queue offer virtually unlimited throughput, but FIFO queues can have like 300 messages per second, but if you enable the batch, you can support up to 3,000 messages per second. So this is the major difference when you will be looking for message ordering and should be looking for FIFO or the standard queue. So there is a throughput difference, so you have to take this under consideration when you're designing a new service for your use cases. Now let's take a look at the working of the Amazon SQS. So there's three concepts first. Let me clear this up. Producers. Producers can be a service or any upstream service which is producing that event or message for you. Queue is offered by SQS. So queue is like where you are putting your event, your messages, or you're sending your messages to. And consumers, they can be downstream services which will be taking these messages and consuming those messages from the queue. So hopefully this is clear. So in SQS, Amazon supports, or AWS supports, two modes of polling. So polling is basically how consumer takes that message from the queue. So there are two modes. One is short polling and the second one is long polling. The short polling, consumer comes to the queue and immediately receives a message. If there is a message, it will get a message. If there is no message, it will be empty message. But this will happen immediately. So there is no waiting around in this. Now long polling, how does that work? In long polling, consumer comes to the queue and it will wait for the timeout. That timeout can be anywhere from 1 second to 20 seconds and wait. And as soon as there is a message in the queue, will be returned to the consumer. So this kind of the benefit that comes with the long polling is that it reduces the number of empty messages. So reduces means that you will not get any empty messages if the message arrives within the timeout period. That can be anywhere from 1 second to 20 seconds. Second, because in SQS, you pay per request. So if you're using short polling, so you can keep hitting the queue for the message, but the queue is empty, you will still be charged for the request that you are taking. So this is kind of useful when you have downtime in your business. Let's say there are no customers coming to your website in the night and you're still polling from the queue. So you will still be charged for that request that you're putting in the night. So it's kind of useful to think about your business, and maybe most of the use cases can benefit with long polling, and you can reduce the cost with that. Now let's take a look at how that will be working. So in the queue, we have three messages, CBA, and consumer 1 wants to take the message A. Because this is available, so they will receive the message A. And as soon as consumers 1 start consuming message A will be marked invisible. What that means, this message will not be visible to rest of the consumers. Even though message is still in the queue, but because of the visibility timeout, this will be invisible to the rest of the consumers for the time period that you are configuring in the visibility timeout. Now, consumer 2 will come and start consuming the message B. Now, message D will be marked as invisible. So consumer A consumes the message and deletes the message within the visibility period. So that means the message will not be consumed by any other consumer, and this is gone from the queue. Now consumer 2 is still consuming this, but consumer 2 crashed during the visibility time period. What that means, consumer 2 was unable to process the message and message was still in the queue. So what happens? The message will become visible after the visibility timeout period. So let's say you have configured some visibility time of, let's say, 2 seconds. this will be available to the other consumers so they can consume this. This kind of useful where you have, spot instances in the EC2, and if this spot instance goes offline, the new instance that you would have added can actually take the message from the queue. And that's a very typical use case where you're looking for optimizing your cost. So you can have like a queue will store that message, and then you can take advantage of the spot instances when they are available. They can take the message and process this, and if they are gone, it will not have any negative consequences on your processing. So let's take a look at the one example, Decouple messaging API. What that means, a user is making a payment through that API gateway. So when you're making a payment, there will be two parts. One, you want to store that payment detail in the customer database. And what we are doing this with the help of the Lambda function. In the Lambda function customer, we are updating this payment details in the Aurora database. At the same time, we want to store that data in the sales database as well. But there is no time sensitivity. So what that does, it's asynchronously, we are putting this message in the SQS queue, sales queue. From the sales queue, there will be another Lambda function which will pull this message and read this from the SQS and update the SQS sales database from there and remove the message from the SQS. Now, let's understand the pricing, because this is an important aspect of SQS. If you're not clear how the pricing is going to work, you can make some wrong assumptions and might cost you something. So in the pricing, how pricing works, for the first 100 billion requests in a month, you pay 40 cents per million request. So 1 million is the unit price in this case. So you're paying 40 cents for 1 million requests in a month. With FIFO, this becomes 50 cents for a million requests. There can be some additional costs for the data transfers if you are, AWS is more liberal now with the data. Historically, this used to cost a lot more for data transfer charges, but there still can be more cost associated with the data transfer if you're transferring to different regions, or if you're transferring data to internet and something like that. So that can add on to the price here, but I'm not putting that in the consideration. There can be some additional cost for KMS and S3 bucket. S3 bucket is useful when you're storing large objects and you're passing the object key in the message to the SQS. This pricing goes cheaper if you use more in a month. This is kind of useful for the big companies. If they're making more requests, they will pay like 24 cents if they go over 200 billion requests in a month. So that's very transparent pricing from AWS. Now let's take a look at in terms of limitations or quotas. So the message size, the maximum is 256 KB. And as I mentioned, you can send large object with the help of S3 bucket. So you can put your object in the S3 bucket and send the object key or reference in the SQS queue. Message retention, it can be anywhere from 1 minute to 14 days. Message delay is 15 minutes. So the delay is a very interesting concept, especially what happens, like similar to the visibility timeout, this offers a delay queue. In this case, what happens, you can configure the delay queue, like we want to have a delay of up to a 15 minute or 2 minutes, 5 minutes. So that way you can allow some more time to the consumer so they can complete the processing, especially let's say when you're placing an order and you want the payment gateway to complete the payment charges before you issue the confirmation email. So you can have a delay of, let's say, if your payment provider takes a minute to process the payment and confirm if the payment was successful, you can configure that delay of 1 minute. And after 1 minute, it will check the status from the payment gateway. If the payment was successful, it will issue the order confirmation email. The second part is in-flight messages. So the messages in the queue at a given moment. So maximum size for the standard queue is 120,000. For FIFO is 20,000. Message attributes, in one message, how many attributes you can have in the JSON or in the payload, that's 10. High throughput FIFO, as I mentioned, is in the FIFO, you can only have 3,000 messages per API per second. With batch, you can increase that up to 30,000. Then visibility timeout is 12 hours. That's the maximum that you can configure. So that's the maximum time you can take to process that message. You cannot go beyond that. Now let's understand the Kinesis data stream. So in Kinesis, it's very similar. It's from the event store from AWS. Now the difference comes, this is kind of more suitable for streaming services, as it's obvious from the name, right? And the second use case is more useful for data ingestion, where you're ingesting large amount of data and then you don't want to miss the data and you have a continuous data stream coming into your service. That's where this comes into play. Now, the difference comes in the data retention. Now, with the Kinesis data stream, you can have a data retention from 1 day to 365 days. So you can store your data up to 1 year. But it's not recommended to store that for a year. You have to think about other durable ways if you need to extend your data retention for that time. Default is 1 day for the data retention. In this case, message order is preserved in a shard. So in Kinesis data stream, you think about it like a founding block or a building block. So a unit in Kinesis is a shard. A shard is very similar to a queue. And this shard here acts more like a FIFO queue. So this ensures your order. So when the message is sent, it's consumed in the same order. Now let's take a look at the working of the Kinesis data stream. So similar to the queue, we have producers, we have consumers, and we have shard A, shard B. They're very similar to queue. So as of now, we are starting with a screenshot that says, okay, snapshot. Sorry, not the screenshot. With the snapshot having 3 messages in shard A, 3 messages in shard B. So let's say consumer 1 wants to consume the message. So what it will do, it will issue a get shard iterator API request to shard A. And as an iterator, it will have the reference point at C. So what it will do, it will start reading from this C. So C message will be consumed with the get record API call. Consumer 1 will receive the message C. Now at the same time, consumer 2 issues a request, get shard iterator, and the reference is at E. So now it will start reading the message E. Okay, now it will start reading C as well as a next message with get record. If you see that consumer 1 and consumer 2, both of them are reading the same message. This is very different to the queue that we have seen. So in the queue, 2 consumers cannot read the same message at the same time because of the visibility timeout. But in this case, consumer 2 can read the same message because the messages are not hidden to the consumers. As long as they are available in the queue and they are within the data retention period for that particular stream or shard, message will be available to all the consumers to consume. So they can consume that. And second, as you can see, the consumer A is slow consumer. Consumer 2 is reading really fast and consuming these messages very quickly. So what that tells you that you can have a different shard iterator that allows you to consume the messages at your own pace. So consumer can decide if they want to consume the messages really fast or slow. And that is really useful because let's take an example. You have a service, and that service is responsible for uploading the images to your servers. So one service is responsible as soon as you upload the data, send the confirmation. The other service is responsible for taking that uploaded data in the S3 bucket, for example, and create new renditions of that image. Renditions means a mobile image and a desktop image and having a different size images and thumbnail and so on and so forth. So creating that renditions or can take a long time. So in this case, consumer 1 can be a EC2 instance that takes, let's say, 5 minutes to generate new renditions or multiple renditions for that image. Consumer 2 is responsible for confirming if that upload was successful. So consumer 2 can move really quickly because it just wants to check if this image was successfully uploaded to the S3 bucket, and once uploaded, it can send a message success that okay, upload is successful. So that's where the use cases for the Kinesis streams comes into play, where you can have different set of the consumers and they can consume at a different speed. Now let's take a look at the Kinesis data stream source and destinations. That is important because you want to see where we can put the data into the Kinesis data stream and how we can actually use that data that is available in the Kinesis data stream. So in terms of the input, you can send this input with the help of the API. So you can integrate with API gateway with Kinesis data stream. So this works very similar to the REST API. So you can just put the message in the queue, in the stream. And at the same time, there is a Kinesis producer library. So KPL, that's something that you can use on your server side to put the messages in the queue. And that can be your mobile app, your website, anywhere, wherever you can deploy that library, you can send the messages. The interesting use case can be from IoT devices. Let's say you're operating in different drone fleets or any other, drone swarms, and you want to send that message, GPS coordinate, or you are let's say you're operating a fleet of different delivery vans, and you want to receive the location of each van where they're operating in real time. So they can all send these messages to the queue. Sorry, I'm keep repeating the same thing. You can send this message to the stream, and this will be available as an input. Now this data can be sent to Kinesis data analytics, so you can visualize the current location and the distance from the different places in the Kinesis data analytics. You can also send this data to Kinesis data firehose if you want to send. And from data firehose, you can integrate to S3 bucket and different excellent third-party systems as well. You can also send this data to Apache Spark on Amazon AMR if you are building any BI activities, like just want to build dashboards and things like that. You can even send that to the EC2 or Lambda functions. So this is the destinations that you can get. So this is really useful from that point of view. Now I will be talking about the standard consumers and the enhanced fan-out offering that we have, and we will take a look at it in detail in this video. But in the top level, this is how it looks like. Now, historically, Kinesis data stream used to be a provision mode where you have to plan your capacity, increase the capacity or decrease the capacity. That was the classic Kinesis. But recently, or I think 2 years ago or something, that they launched the on-demand Kinesis data stream. So what that means, with on-demand, you have simple to use. You don't have to think about the capacity management that we had to do before this on-demand Kinesis data stream was available. Flexible scaling, what that means, you can scale up and down in response to the data volume that you're receiving. You can think about high availability. So as soon as one of the shard is going offline or something goes wrong with that shard, you can quickly add a new shard automatically. You don't have to think about the underlying hardware from that point of view. So it's highly available and fault tolerance by default. Plus, because now we are optimizing the capacity, so this allows you to reduce your cost because you are not over-provisioning the capacity. Most of the companies end up over-provisioning that capacity. With this, you don't have to do that. So these are the four key benefits that you get with the Kinesis on-demand. However, there's a downside. With on-demand, you have to pay more price. It's expensive because, there are extra features that you're getting, so you have to pay extra price for this. Now, as I mentioned, in Kinesis data streams, there are two different models. One is the standard consumer model. In the standard consumer model, what it does, you can get up to 2 MB of read throughput, and you can read 5 reads per second. So essentially what you're getting, average latency of 200 milliseconds with the consumer model, standard consumer model, and you're getting 2 MBs of data per second. That's the kind of the response that you're getting. So if you are able to fulfill your business use cases with this, it's really ideal because it's cheaper. But there is a second model, consumer model, is also available from the Kinesis data stream. That's called as enhanced fan-out. So with enhanced fan-out, what we get dedicated 2 MB per second per consumer. So with that, the latencies can be as low as 70 milliseconds. So this is useful where you have to have, multiple consumers, and you have to ensure that, the throughput that we're getting is not fulfilled. And to have that extra capabilities, you can think about using enhanced fan-out models. With enhanced fan-out consumer model, you pay more money for this extra feature, but this can be useful if your business is looking for this kind of the use cases with low latency and high throughput use cases. Now let's take a look at the real example in the real-time streaming analytics pipeline. So as I was saying, the input, so you can have that input from the end user transaction. So from there, they're putting the events and the messages in the Kinesis data stream. From Kinesis data stream, we have two consumers now. One is Kinesis data analytics, second is Kinesis data firehose. You can have multiple consumers for the same message, right? As I mentioned before. So now we are going to have hot module. Hot module is something that we want to process this data as soon as possible. So we are putting this in the Amazon Kinesis data analytics. That's real time. From there, we are able to have a AWS Lambda that is fanning out and sending the process information that we have received from analytics, where you can do some rules processing. And from there, we are able to put that event and into different topics that is available in the Amazon Simple Notification Service, and then you can configure emails and other different use cases. Second, you can also send the data from the fan out into DynamoDB if you want to update that in terms of visualizing the records that is coming in, or any of the use cases that is used by another web application. The cold module, that's usually like for archiving purpose. You can have the Kinesis data firehose, and from that we can store the raw data in the S3 bucket. This can be used for archival purpose, or can be used for building some other interactive queries, like using Athena. You can build your query, analyze that data, and run queries against that data to identify the useful insights from there. Now let's take a look at the pricing. So in KDS, Kinesis data stream pricing, there are two modes, as I mentioned before: provision mode, second on-demand mode. In provision mode, you pay shard hour plus payload units. And if you are using enhanced fan out, you pay for enhanced fan shard out model plus data retrieval. So there are basically four types of pricing that you have to pay in provision mode. And the on-demand mode, there is no shard hour concept. You only pay for stream hours, how many hours you are using that stream for, plus data ingestion, plus data retrieval, and any enhanced fan out data retrieval. So this is what you have to pay. And the third one is the data retention. So if you're using default 1-day data retention for the Kinesis data stream, that's free. But if you want to increase the data retention, you have to only pay for the extended retention period that you're using. So if you can, you can extend up to 365 days. So you have to pay extra for the data retention. Now, in terms of the Kinesis data stream quotas, so you have put records. It's 1 MB or 1000 messages per shard per second. You can have up to 1000 shards. So you can scale to that if you have that kind of the workload that you have to support. Get records, you can have 5 transactions per second or 2 MB per shard per second. So as I mentioned, you can have multiple shards. So you need more throughput, you can use that. Or you can use enhanced fan out as well. Now, let's take a look at the key differences. So I have already covered most of the key differences when I was talking about Kinesis and SQS, but in a top level, if you have to summarize this in a clean way, this is how it looks like. On the left, we have some features that we can compare and how that looks in terms of Kinesis data stream and SQS. So consumers, with Kinesis data stream, you can have more than one consumer. In SQS, you can only have one consumer per message at one time. Latency, Kinesis has a propagation delay of less than 1 second and is mainly affected by consumer polling interval. SQS latency is low in hundreds of milliseconds, but in some use cases, if you're using short polling, you can achieve in less than 100 millisecond latency as well in some use cases, where you can optimize the data consumption and short polling from that point of view if you really need that kind of throughput. The message size in Kinesis data stream is 1 MB. That's the maximum size of a message that you can have. In SQS, you can have a message of 256 kilobyte. Message replay. In Kinesis, you are storing that data for retention. You can replay the data that is available because you can always get a new shard iterator in your application if something goes wrong, and you can start reading that data from there. In SQS, as soon as you read that message and consumer successfully processed, consumer will delete that message from the queue. So this message is not available in the queue. So you cannot replay that from that point of view. Second, message visibility. In Kinesis, the message is available for the duration of the data retention, so there is no invisibility concept in Kinesis data stream. In SQS, however, you can configure that visibility timeout, which allows that only one consumer can consume that message for that visibility timeout period. In failure management, Kinesis do not offer any inbuilt data letter queue facilities. However, SQS will give you a very granular per event acknowledgement of failure guarantees. So if you want to have that kind of guaranteed delivery, then SQS will be the right service for you. If you don't need that kind of the data letter queue facility, Kinesis will be suitable from that point of view. So as you can see, that 4 key things that you should be looking for when you're going to compare if you want to use Kinesis or if you want to use SQS. It comes to the number of consumers that you're looking for, the message size that you should be looking for if you want to have some sort of a failure management or not. These are the key criteria that you should be looking for in terms of choosing the right service for the workload. Now, let's take a look at in the industry examples where you can use Kinesis data stream. So Kinesis data stream, as you can imagine, that's kind of used to process large amount of data in real time. And in-order messaging is important. And your service, downstream service or consumer in this example, should not receive any duplicate messaging. Then Kinesis is the right service for you. The typical examples can be fraud detection, real-time analytics, gaming, real-time data pipelines that we have seen earlier. And if you have to think what that means for SQS, SQS is a good choice for application that need to send and receive message asynchronously. So what that means, if you want to have some sort of a decoupling between the producer and the consumer, then SQS is right for you. And the example can be if you are using spot instances in AWS, then SQS will be really suitable, where you will be putting all the queue or messages in the queue, and then that allows to have a buffering or throttling effect, and you can process the event when the spot instance is available to you. Typical example, microservices architecture, batch processing, payment processing,